Welcome to the double replacement reaction lab. The double replacement reaction occurs if anything other than an aqueous compound is made. If everything in the reaction, all the reactants, all the products, if everything is aqueous, which means the ions have not recombined into anything interesting, all the ions are held apart by the attraction to water in solution. That's what dissolving is. You've got water and the polarity of water, because of the strong difference in electronegativity between the hydrogens and the oxygens in water, pulls ions apart. It takes that solid crystal that you put into water and it pulls those positive cations and negative anions away from each other, and then passes them around in the water like a chemical square dance. All right, so things you're going to see on this list right here are evidence that a chemical reaction has taken place, or you've had a successful double replacement reaction. We want you to look really closely at your products today. You've got a hand lens, and if you can't see very well what's in there, you've got a flashlight, and here are all of your chemicals. Let me show you what to do. Each of your lab benches should have a reaction grid, and your reaction grid should be in a plastic sleeve. You'll be taking each of your reactants, like for instance here silver nitrate, and put a drop on the grid where it's supposed to go. You can see your silver nitrate right here. And then to save time, since that entire column is silver nitrate, go ahead and put a drop in each of the rectangles on one side of each of the X's, all the way down. Then you can hand that silver nitrate over to the partners on the other side of your lab bench. All right, here's my iron 3 chloride, and I'm going to react that with the silver nitrate. You just need one drop. And of course, if I were to do this entire lab for the video, I'd put another drop right there as well. Get all your drops set up first, and don't worry about mixing them until your grid is all full. That is when you'll need your glass stirring rod. Right? So take your glass stirring rod, of course make observations here first, and then on your lab sheet here you can write what the solutions look like before you stir them together. So the silver nitrate is colorless and clear. The iron 3 chloride is also, transparent and yellowish. And then you stir them together. And you can see that the solution has become milky. And it's a description that you can add right here. So start it out, and then at the bottom, what did the products look like? That milkiness takes the solution and it turns it, you can still see the X through it, so it turns it from transparent to semi-transparent. And a semi-transparent solution is an indication that there are suspended solids. Maybe you can even see those suspended solids if you use your hand lens and your flashlight. After each time that you mix your reactants together, you have to bring your stirring rod over to the sink and rinse it off. And that's to prevent cross-contamination, so you don't get false positives or reactions that were unintended. And The tap water on there is fine. Just rinse it off. You don't have to wipe it off or dry it. And then you'll continue to your next square. Do the same thing. Rinse. Do the next square, and so on and so forth. I'm sure you get it. I just want to reiterate the importance of the hand lens in the flashlight. Some of the reactions appear to not have any solids made or any bubbles or gases made, but what I want you to do is assume that every reaction should produce something that's not aqueous. And double check with your hand lens. Get in there really closely, flash the light on it, see if you can see tiny little particles. And call us over if you can't see anything in the products of what you stir together. All right, now this is all for your observations. Make sure it's completed. This is all for your reactions. So your reactants and your products, these all have to be balanced reactions with states of matter. And there's a note here at the bottom. Make sure you add states of matter. Your last step is cleanup. You're going to have this grid full of products from your reactions, and pay really close attention to where the opening in the sleeve is. And I'll show you why. You're going to take this grid, and now imagine it's full of reactions, and you're going to let all those products slide together and mix in the middle. You're going to walk this over to one of the DRR waste buckets. So there's our double replacement reaction waste bucket here. And you are going to make sure that it all pours out, all of your waste pours out into that bucket, and the side of the sleeve that it pours over is the closed side. If it pours the other way over the open side, as you can see, this has happened in the past, it'll get the paper wet, and through capillary action and water tension, the products will contaminate the paper. All right, so put your right hand over your heart. Repeat after me. I promise to pour my waste over the closed end of the plastic sheet. Great, thank you very much. Once you do that, take the paper towel and wipe down the entire plastic sheet and return it to your lab bench for next period. All right, thank you. Have a good lab.